Now after this, what we have to do is we are going to learn about, now we are going to talk about a few more types. Like we are going to talk about unknown type. Unknown type is very important, and a lot of people actually are confused between unknown type and any type. So I'll just give you a very basic difference. So suppose for example you are just saying that something is not known right now. Something is not known right now. So how can you do that? Suppose if I say let some value, and this is a string, okay, and I would just try to say that if some value was a number, then only I would perform some operation. I would always perform some operation. For example, I would just say that we have a variable, okay, we have a variable and some number, okay, some number, and I would just say that it's of type number, and initially suppose it's 0, okay, and here I want to say some value equals some number, equals some number. Can it be done? Okay, I'm sorry, some number equals some value. That means some number which is of type number is equal to some value. Is it possible or not? Is it possible or not? So if I try to uh, run this, if I try to run this, let's see what's the problem here. If I try to run this, so you can see it's totally fine, and you are actually getting it like this, right? Why it's working like this? Because you can actually see that it's of type any and it's of type number, so automatically some num is like this, okay. And suppose if I write if I try to get the type of some num, okay, that means I want to get the type of some num, what would happen? So again I would compile this, and then I would just run this. So you can see the type of it actually now became a string, okay. So if you want to change the type from any to number, it can be easily changed, right? So like from number to any, I'm sorry, from number to any, it can be easily changed. So you can see I changed the type to string, right? But instead of this, I want to just do something else. For example, I don't want to do this. I don't want to do this. I just want to say that if some value is containing a number, then only assign the value. Okay, I don't want to assign a string to a number. I don't want to do this. I want to say, suppose if it was a number, suppose it was a number, then only change the value. Okay, in any case, you can do this, you can't do that, you can't do that. But if it was unknown, but if it was unknown, okay, unknown, I'm just saying right now the type is unknown, and after that you can actually add some if else statements. You can just say that if the value of some value is number, then only help it to modify the sum num. That means I'm just saying if its value is number, if its value is number, then only change the value of sum num. That's what I've said. Okay, so that's how unknown actually helps us, and in a lot of case unknown is preferred. And unknown and any types in TypeScript both provide flexibility while dealing with values of unknown and dynamic types. That means if you don't know what's exactly there, but if you want to perform on a specific type, then you can do this. Suppose instead if it was some string, okay, if it was some string, so you would actually say, you would actually say, suppose if suppose some value was string, okay, then I would just make some num as so like this, okay. So for example, if I now try to print this console.log some number, and here right now if I try to print this, what would happen? I must get 12, okay. So I must get 12, so you can see I'm getting 12. Suppose if I make it a string, suppose if I just make it a string, okay, now what I must get? So I would compile this, and now I would just run this. So you can see I'm getting this, okay, because I provided a string, so it would give me this value. If I provide a number, it would give me this value, right? So I hope you understood the purpose of unknown, and you'd be using it. It's actually safer than any. When a value is of type unknown, the TypeScript restricts what you can do with that value unless you narrow its type and perform a type check. That's what we are doing. We are just performing a type check, right? That's what we are doing, right? So acha, if I suppose directly write this, what would happen? Suppose if I directly write this, I would just say some num equals some value. What would happen? So you would see that I start to get an error, because you can see unknown is not assignable to type number, because you can't assign unknown to anything, okay. You can't assign unknown to anything. You can see it was a number. I'm assigning number to unknown. I can't do this. Okay, so to do these kind of things, you have to perform type checks, right? So that's why unknown is better, and in any case you can easily do it, but this would cause problems, right? So in unknown we can perform type checks, and it's always beneficial in our case, right? It would save us from very big problems. So that's the difference. So now guys, we are going to talk about functions. So now we are going to talk about functions, very important. So functions are very easy, right? So you would just say your function is very easy. For example, you have a function of adding something, so you would just write it here, and it's actually returning what, a plus b. So I'm just going to say whatever the function is returning, I would always specify it here. That means function is returning a number value. I'm specifying it here. Suppose in case by mistake I'm returning a string, so it would give me problem. It would give me error. So you can see string is not assignable to type number. Okay, so yeah, it's always beneficial to give types to this number so that we are known that what kind of things we are returning. So I'm just saying I want to always return a number as the sum, so I am returning the number as a sum, right? That's how it actually works. Now similarly, you can give some different parameters with different types to this. For example, I'm just saying we have one function which is taking name as string and age as number, and it would return this string at the end. That is, the type is return type is string. Okay, so that's how you can give different types to a function. And here greet is a function that takes name parameter of the string and an age parameter of type number. So it explicitly specifies that the function returns a value of type string, right? That's how we have specified it. So after this we have optional parameters also. So again, I told you we put a question mark for options, so I will again write it like that. So I would just say we have a function which says hello. So I'm just saying we have a function which says hello, and its return type is what, string. Okay, its return type is, I'll just write it like this, so string. And here guys, I would just say that I'm just saying that if greeting exists, then return this string, else return something else. Okay, okay, so it's like if greeting exists, then return this. If greeting doesn't exist, then return this. Suppose instead of this, if I just directly write it like this, what would happen? If I write directly like this, what would happen? So you can see it would run properly, but if you don't provide greeting, we have to check that. So we would simply say let result is result of this say hello is what, so we are just saying that suppose this is the name and this is the string, and now let me just try to print this. So it would obviously return good morning Chris, right? So let me just try to run this, so you can see that it's running properly. But suppose if I don't provide this, what would happen? So you can actually see that it would again run like this, and you can actually see I'm getting undefined. So it's pretty long, right? I'm getting undefined. So in that case, you actually can easily provide this if a statement, and it would do the job for you. Okay, so you can see if in this case you are trying to run this, you can easily see that we are getting just hello Chris, and if greeting is provided, you would run this one, right? That's how it easily works, and that's how you can manipulate the functions according to the data, right? So this was optional parameter. If greeting is provided, then something would happen. If greeting not provided, something else would happen. So it's based on option, right? So now after this, I'm just going to provide some default parameters also. For example, some value is not provided, so I'll just give some default parameter. For example, we have a function here, so I'll just comment this out, and I would just say we have a function here which simply says hello. But suppose if you don't provide any message, so if you provide a message, it would simply give you message. Suppose you don't provide the message, so what we would say, we would simply give hello as the value of message. So let's see how it actually works. So I'm just saying if I don't provide any value, you would see that what's exactly it would provide. So this is it. Actually, this slash is not required, it's got by mistake. So you can see I'm getting hello because I didn't provide anything. But suppose if I provide anything, okay, suppose if I provide anything, what would happen? So obviously it would again check and this time it would provide the value which you have provided. So this is the default value. If message is not provided as a parameter, so message equals hello and hello would be printed. That's it. Okay, so now we are going to learn about type annotations also. So again, you are just going to define a type for the function itself, and later on you are going to use that. So I'll just say, for example, we have a function, so I'll just say type, and I'll just say math operation, for example, math operation. I'm just saying that if I provide a and b, it must return a number. That means if I provide two numbers, it must return a number. That's what I have defined as a type. So I'll just say let, we have a function of add, and I'm just going to say that its type is what? Its type is what? Math operation. That means it would be taking numbers and returning a number. That's it. Okay, it's returning a number. That's what I've said. Okay, so that's how it actually works here, and that's how the type annotation would help me. So I'm just saying that we actually we don't need these. Okay, so we are just saying that the type annotation would simply help us. We would just simply provide a and b to this very easily, and at the end it would just return this. Okay, it would just return this, right? That's how it actually works. So I'm just saying that this add would be taking reference from here, and all these would be automatically taking types of these. That's how it actually works, right? So guys, I hope you understood this. Now what else do we need is we are going to actually, you can make it an arrow function also. uh, like this, so you can make it an arrow function, right? So that's how it actually works. So yeah, it's just saying that once you write it like this, automatically a would become number, b would become number, and return would become number because of this, right? So you can actually create a blueprint and use it as an annotation for your function. So the math operation is a type alias or the function that takes two number parameters and gives a number, and the add variable adheres to this function type and returns accordingly.